Hello guys, welcome to this video. In this video I'm going to introduce you to a very important equation when you are actually dealing with fluid mechanics. So Poiseuille's equation here is actually very useful in trying to determine the flow rate of a viscous fluid. That means a fluid which has got some internal friction, which is known as viscosity. So Poiseuille's equation here will be used to actually solve an equation such as the one given in this question, rather in this video, and I'm just going to show you around on how to find the pressure difference in this case between the input and the output of a needle. Right, so Poiseuille's equation is given as the volume flow rate, which is equal to pi r to the power 4 times the change in pressure, or the pressure difference between the 2 points, divided by 8 multiplied by the viscosity and the length of the needle in this case. All right, so one thing I want you to notice here before we go ahead is looking at the rate, the flow rate that we are given in the question, and the flow rate that is actually required by this equation. All right, so in the question here we are given the flow rate in terms of grams per second, but Poiseuille's equation actually gives the rate in terms of the volume flow rate, which may be cubic meters per second. So now the first step will be to convert this flow rate from grams per second to cubic meters per second. Okay, so now let us go ahead and write some of the data that we have, and then we're going to find an expression for the pressure difference and simply substitute these values, and we should be able to evaluate the pressure difference between the input and the output. Okay, so what we have here is the flow rate, which is the mass flow rate in the question. Okay, so we have the mass flow rate, dm dt, which is going to be 1 gram per second. All right, then we also have the length of this needle. Okay, the length of the needle given as 0.03 meters. So we're going to have to convert those millimeters and centimeters to meters actually. So the radius is simply half of the diameter, and the diameter that we have there is in terms of, okay, so the diameter that we have is in terms of the millimeters, so we take that to meters, and we're going to have the radius being equal to the diameter over 2 converted to meters. That will be like 1.5 times 10 to the minus 4 meters. Okay, so that is our radius over there. Then the viscosity, we have 1 times 10 to the power 23 pascals per second. All right, so these are the values that we have. Then we also have the value for pi, which we already know, about 3.14. all right, so now that we have the data, the only step that we require now is to convert this guy from grams per second to cubic meters per second. Okay, so let's go ahead and do that. So what we should know here is that to convert from grams to cubic meters, okay, we have 1 cubic meter being equal to 10 to the power 6, okay, grams. So what this tells us is that 1 gram actually is equivalent 10 to the minus 6 cubic meters. All right, so if that is the flow rate that we have, then we're going to say the flow rate in terms of the volume here, okay, which is our Q, therefore becomes 10 to the minus 6 cubic meters per second. So this is the flow rate that we work with, and it is the value that we're going to substitute and use to determine the pressure difference. Okay, so again, remember, Poiseuille's equation is given as the volume flow rate, which is equal to pi r to the power 4 multiplied by the pressure difference over 8 multiplied by the viscosity multiplied by the length. So from this expression, we're able to find the expression for the pressure difference as the flow rate, which is the volume flow rate, multiplied by 8 tau by L over pi r to the power 4. Okay, so it has become much easier now that we have our flow rate in terms of the volume and the rest of the other parameters given. We just substitute those values and simply compute the pressure difference. Okay, so what we'll have is going to be the pressure difference being equal to 8 multiplied by 1 times 10 power 23 multiplied by 1 times 10 minus 6 multiplied by 0.03 over pi multiplied by 1.5 times 10 to the minus 4 to the power 4. Okay, so once we substitute these figures, and we just a matter of computing using a calculator. So I'm going to leave this part out for you. Okay, you should be able to get the pressure difference between the inlet and the output, okay, of this needle.